Hello again. This is Max Bright at Lower Umpqua Library, bringing you another video in our science program. Today, we're going to talk about magnets and understand how they work. Magnetic fields are created anytime we have moving charged particles. We've talked about some charged particles before. We discussed atoms, which make up everything that we interact with every day. At the center of an atom is the nucleus. Inside of that nucleus are positively charged protons and neutrally charged neutrons. And then moving around the nucleus are negatively charged electrons. Those moving electrons create little tiny magnetic fields. Let's look at a magnet and discuss some of the features of a magnet. The first thing to notice about a magnet is that there are always two poles, the two sides of the magnet. We call these the North Pole and the South Pole. And even if you were to cut a magnet in half, you wouldn't have a North Pole and a South Pole separated. You would actually be creating two separate magnets, one with a North and a South Pole and another one with a North and a South Pole. There's no such thing as a monopole. You can't get one pole by itself. When we look at these poles, we find out that opposite poles attract each other and the same poles repel each other. Let's take a look at that. So I'm going to lay down the magnet here and I will bring in the other magnet and use the opposite pole. And we can see that they were attracted. Great. Now what I'm going to do, place the same magnet down the same way and flip over the other magnet. Now I've got the same side poles going together and I'm able to get them to touch, but look what happens when I let go. It jumps off, it gets repelled, it gets pushed away by the other magnet. So that's one way to check whether the poles are the same or opposite. If they're the same, they repel, and if they're opposite, they attract. Then one more thing we want to know about magnets is that they can attract paramagnetic materials. So a nail by itself isn't magnetic. I can check that by bringing it near some paper clips. And you can see it doesn't attract those paper clips at all. But if I bring the magnet in, the magnet attracts all of those paper clips. And if we even flip the magnet around to the other pole, it still attracts the paper clips. So magnets attract paramagnetic materials, but paramagnets cannot attract other paramagnetic materials. But look at what happens when I put the magnet onto the nail. All of a sudden, the nail acts like a magnet. I've also got a compass here. Compasses are used to detect magnetic fields. Let's see if we can do that here. And you can see there's an arrow here that points to the north magnetic fields, and then south is on the opposite side. Inside of a compass, there actually is a magnet. And if I bring another magnet nearby, it attracted the north side. Inside of the compass, the magnet has been flipped, so it's actually pointing to the north side. It isn't the north side of the compass magnet. This is the north side of the magnet. If I flip the magnet over and bring it near the compass, you can see the compass react and it points to the south. So there we can see which pole is which. It was a lot of fun. You might have some magnets in your home. Sometimes magnets are used to keep pictures on the fridge or report cards. So try some things with magnets and let us know here at the library. To see more videos like this, go to luld.org and feel free to call us for any questions about our science program at 541-271-3500. We'll see you next time. Bye.